will be dealing with enthalpy. Most physical and chemical changes nag-occur sila at constant pressure. So in our topic today, in our discussion today, we will define a thermodynamic variable that makes it easier to measure energy changes at constant pressure. So first, let us define the meaning of. Okay, but before that, let us recall that in determining the internal energy, so dito na naman, nagbago na naman yung internal energy natin, naka-in na naman, and supposed to be, it should be in. Huwag kayong malilito. When we say internal energy, guys, this is, diba sa previous discussion natin, ginamit kasi natin is U. So, dito na naman, naka-I na naman tayo, but don't mind that, huwag kayong malilito. Ang internal energy, ang E natin is the same as the internal energy. Ayan. So, in determining our internal energy, we measure both heat and work. Diba? Yung mini-measure natin yung Q and W. But right now, dito sa enthalpy natin, in our discussion here in enthalpy, I will introduce to you a new form of work. A new form of work na dito hindi directly i-state kung ano yung kung ilan yung work na na-perform ng system natin. Okay, wait lang. Mag-accept tayo ng. So dito sa nakikita nyo dito sa diagram natin, this is piston, may piston cylinder tayo dito. So makikita natin dito sa initial state natin, na-compress yung system natin. Na-compress yung system natin, so yung initial volume natin is lesser compared dun sa final volume natin. Makikita naman natin dito sa diagram natin. So dito, ang tatandaan lang natin dito, meron tayong tinatawag na PV work. Meron tayong tinatawag na PV work. So etong PV work natin na ito, this is the work done in the form of pressure and volume natin. So makikita natin dito, constant ang pressure natin, but then ang volume natin is nag-increase. So kapag nag-increase ang volume natin, 'di ba? Maalala nyo sa chemistry natin, meron tayong tinatawag na expansion. Kapag nag-expand ang gas natin, ang work na na-perform natin is negative, always negative. Tandaan ha, kapag ang system natin is kapag ang system natin or ang gas natin ay nag-expand, nag-undergo ng expansion, ang work na mapoproduce natin is always negative. Tandaan, it's always negative. So, yan ang work na na-perform natin. Dahil nga nagkaroon tayo ng change in volume, may work na na-perform, ang tawag natin doon is PV work. Work done when there is change in the volume of our system. Negative kasi ang nag-exert ng work dito, ang nag-perform ng work dito is our system. Ang system natin ay nag-perform ng work, kaya negative ito. Work is done by the system. Okay, so dito tayo sa meaning of enthalpy. So, the enthalpy of a system is defined as the internal energy plus the product of the pressure and the volume. So, the change in enthalpy is given by ito. Change in H is equal to change in internal energy plus our PV work. So, makikita natin dito na, okay, later na lang yan. So, internal energy. So, paano tayo nakapag come up with this equation? Paano tayo nakapag come up dito sa dito sa change in enthalpy na equation natin. So, eto ang nangyari. Ang internal energy natin, maalala natin na ang internal energy natin ay ang internal energy natin is equal to Q plus W. Q plus work. But in our discussion today, ang work natin is in the form of PV work. So, ang nangyari, Q plus ang ating PV, negative. Since expansion, itong nangyari na work natin, this is negative PV. And then, kapag kukunin natin yung in terms of Q, kasi ang enthalpy, sabi natin, di ba, enthalpy is the heat of reaction. So, kapag kukunin natin yung Q natin, itatranspose lang natin. So, Q, this will become Q is equal to change in U, change in internal energy kapag nilipat natin sa kabila, plus P change in V. So, we see, etong Q natin is the same as enthalpy. Ayan, kaya nagkaroon tayo ng gantong equation. Ganun lang yung derivation natin ng equation na ito. So, in this, the change of enthalpy, ayan, the change of enthalpy, ito, the change of enthalpy is equal to the heat gained or heat loss. Ayan, heat gained or heat loss at constant pressure. Kaya meron tayong subscript na P dyan. Ayan. So, lalagyan natin dito ng subscript na P. Kasi at constant pressure tayo. The change in enthalpy is equal to the heat gained or heat loss at constant pressure. So, ito lang ang working equation natin for the change in enthalpy. Tandaan nyo lang to. Change in H is equal to the internal energy plus the PV work. Okay, dito naman tayo sa exothermic and endothermic process. So, we are already done dito sa topic natin na ito in our previous discussion. But, right now, i-relate lang natin kung ano ang relationship ng exothermic and endothermic process sa enthalpy natin. So, dito sa enthalpy diagram natin, makikita natin dito na meron tayong involved na reaction. Dito sa first na reaction natin, this is a combustion process. And dito sa pangalawa is the melting of ice. Ayan. So, dito sa exothermic process natin, enthalpy diagram for exothermic and endothermic processes. Dito sa A natin, this is exothermic process, methane burns with a decrease in enthalpy because heat leaves the system. So, makikita natin dito na ang enthalpy change kasi guys, ang enthalpy change natin is equal to H final minus H initial. So, makikita natin dito sa diagram natin na yung final na enthalpy natin is lesser than the initial, di ba? Yung initial natin is nandito sa part na to and our final is nandito. Meaning to say, when it undergo exothermic process, loss of heat or heat out, ibig sabihin ang ating enthalpy, ayan, ang ating enthalpy is lesser than 0 or negative. So, dito sa exothermic process natin, ang ating enthalpy ay negative. Dito naman sa endothermic process, ayan, endothermic process, ice melts with an increase in enthalpy because heat enters the system. Diba, kapag magme-melt tayo ng ice, of course, may heat na involved, may papasok na heat dun sa system natin, which is yung ice, kaya magme-melt. Heat enters the system. Therefore, makikita natin ang ating final enthalpy is greater compared dun sa initial na enthalpy natin, and the process is endothermic. So, when a system or when a certain reaction undergo endothermic process, our change in enthalpy or change in heat of reaction ay positive. So, yun lang ang relationship natin kapag endothermic, heat is lost. So, ang enthalpy natin, change in enthalpy natin ay negative and lesser than 0. Kapag naman ang process natin ay endothermic, of course, it makes sense, mag-enter ang heat natin, so tataas ang change in enthalpy natin. So, ibig sabihin, our enthalpy is positive, greater than 0. So, dito, in each of the following cases, determine the sign and state whether the reaction is exothermic and endothermic process. So, dito pala guys, dito sa exothermic and endothermic process natin, dito sa enthalpy, we need to i-imagine natin na ang heat natin is a reactant and a product. I-imagine natin na the heat act as a reactant or a product. So, makikita natin dito sa first na reaction natin, this is, on the first reaction, ang ating heat ay nasa product side. Heat is on the product side. So, tingnan natin, i-check natin dito sa enthalpy diagram natin. When it is exothermic process, nasa taas yung reactant natin and nasa baba yung product natin. So, makikita natin dito na ang product natin ay ang heat natin is nasa product. So, kapag magbe-base tayo dito sa enthalpy diagram natin, nandito sa product, so ibig sabihin, bumaba yung enthalpy niya. So, ibig sabihin, this is exothermic process. So, our first reaction is an exothermic process. Sa next naman na reaction natin, B, tawag dito, our heat, ang heat natin is nasa reactant side. So, kapag nasa reactant side, tingnan natin yung enthalpy diagram natin. Kapag endothermic process, nasa baba yung reactant and nasa taas yung product. So, dito sa problem natin, nasa reactant yung heat natin, heat involved dito 40.7 joule. So, the reaction is endothermic. The enthalpy diagram appears in the margin or in the bottom. So, ayan. So, ang tatandaan lang natin, kapag ang heat involved natin ay nasa product, exothermic, kasi diba, it makes sense, kasi mag-e-exit yung heat natin, so nasa product na siya. So, dito, kapag ang heat natin, kapag ang heat involved ay nasa product, this is exothermic. And kapag nasa reactant, endothermic. Okay, next. Okay, dito naman tayo sa measurements of heat. So, we know that in our everyday experience that the more you heat an object, the higher the temperature, 'di ba? Common sense. Habang pinapainit mo yung object, tumataas yung temperature niya. So, that is the quantity of heat and the quantity of heat absorbed by an object is proportional to its temperature change. Or, 'di ba, sa math subject natin, kapag meron tayong proportionality symbol, yung ganyan. To make it equal sign, magiging Q is equal to magkakaroon tayo ng constant T. Or, ayan, Q over change in temperature is constant. So, every object has its own heat capacity. The quantity of heat, when we say heat capacity, this is the quantity of heat required to change its temperature by 1 Kelvin. So, ang ating heat capacity, this is the proportionality constant in the preceding equation. Diba dito, meron tayong Q over change in T is equal to constant. So, dito, yung constant natin, itong constant natin na to, this is the heat capacity in units of joule per Kelvin. Kasi ang unit ng Q natin, diba, is joule. And ang ating temperature is in Kelvin. Another related property is specific heat capacity. So, kung maalala nyo, itong specific heat capacity sa book natin, ang specific heat of capacity is C lang. Pero usually, ito is nasa in the form of Cp, ganyan, kasi at constant pressure. So, this is the quantity of heat required to change the temperature of 1 gram. So, wag kayong malilito kapag sinabi natin na heat capacity, ang involved lang dito ay yung energy or yung heat natin all over the temperature. Kapag specific heat, may involved dito na gram. So, ayan, the quantity of heat to change the temperature of 1 gram, meron tayong involved na mass of a substance by 1 Kelvin. So, ang specific heat natin, ang equation natin dito, specific heat, Cp, yan, Cp is equal to Q all over mass times the change in temperature in units of joule per gram Kelvin. So, kapag meron na tayo, merong sa mga magiging problem natin later on, so, kapag merong, usually ang tinatanong dito sa specific heat capacity sa mga problem solving dito, ang usually na tinatanong sa atin is yung Q. So, kung alam naman natin ang value ng specific heat capacity, makakalculate natin, we can be able to calculate the heat. Ayan, itong heat natin dito, the heat involved, so magiging Q is equal to M Cp delta T. MCP delta T. Another thing pala, hindi ko nadagdag dito, meron din tayong tinatawag na molar heat capacity. So, closely related to the specific heat. Ayan, the specific heat capacity is the molar heat capacity. So, dito naman sa molar heat capacity, kapag specific heat capacity, this is small c. Small c kapag molar heat capacity, kapag molar heat capacity, ang ano niyan is capital C. Capital C. Molar heat capacity. So, eto naman, this is the quantity of heat required to change the temperature of 1 mole. Dito naman, dito sa specific heat capacity, 1 gram ang involved. Dito naman, 1 mole. 1 mole of a substance by 1 Kelvin. Ayan. So, eto yung mga common. Nasa ano nyo to? Nasa handbook natin later on. Kakailanganin nyo din tong mga to sa mga higher subjects natin sa thermodynamics natin later on. Kakailanganin natin tong mga specific heat capacity. So, siguro by that time, you already have your handbook na baka kapag mga third year, ganyan, may mga handbook na kayo, nasa handbook natin tong mga specific heat capacity natin. Mahahanap natin to sa mga table natin doon. So, but this time, familiarize yourself muna since wala pa naman kayong handbook dito sa mga specific heat capacity natin. Okay, so let's have an example. A layer of copper welded to the bottom of a skillet weighs 125 gram. How much heat is needed to raise the temperature of the copper layer from 25 degrees Celsius to 300 degrees Celsius? So, ang tinatanong sa atin is heat. So, ayan, di ba sabi ko kanina, usually sa mga gantong problem, ang tinatanong sa atin is heat. So, eto ang gagamitin natin yan. Okay, so first thing that we will do, wait lang at kung kamay ko na naman ay okay, the first thing that we will do is to list all the given. So, our given here, temperature natin, okay, so i-calculate na lang natin. Ang change in T natin would be 300 degrees Celsius minus 25 degrees Celsius. This is equal to 275 degrees Celsius or 275 Kelvin. And then, ang wala pa sa atin, ang ating mass. Ang ating mass ay 125 gram. And, wala na. And, ang ating CP ay, dahil hindi given, titingnan natin dun sa table natin. For copper, this is 0.387 joule. So, for copper, this is 0.387 joule per gram K. Wait lang. May nag-enter ba?
Ma'am, mali po ata yung conversion sa temperature.
No, pareho lang kasi in ang tawag dito, in calculating the change in T, guys, ang unang gagawin natin is to convert it to Kelvin. Magiging pareho lang naman ang sawat kapag 300 plus 273 minus 25 plus 273, pareho lang din naman na 275. Wag nyong gagawin na 300 minus 25 degrees Celsius equals 275. Pag magpa-plus 273 pa kayo dito, mali na. So, ang gagawin nyo, diniretso ko lang, ang gagawin nyo muna, i-convert nyo muna tong 300 degrees Celsius to Kelvin, etong 25 degrees Celsius to Kelvin bago kayo mag-subtract. Pareho lang naman ang lalabas. 275 pa rin, di ba? Pareho lang?
Pareho lang po.
Yeah. So, pareho lang. Basta wag nyo lang dediretsuhin na kapag minainas nyo na, tapos mag-add pa kayo dito ng 273, mali na ka. So, ito muna. I-convert muna bago mag-subtract. Okay. So, pwede na tayo. May given ang lahat. So, our answer would be Q is equal to M 125 gram times MCP 0.387 joule per gram K times 275 Kelvin. So, cancel. So, our Q would be ano ang Q natin, guys? Pag-calculate nga.
Ma'am, 13,303.13 po.
13,300. Ano yun? Pakiulit. 13,300.
13,303 po. 303 po.
303 joule. So, this will be our final...
Ma'am, may point 13 po.
Oh, ganyan na. So, yan guys. Ganyan lang kasimple mag-calculate ng heat needed to raise the temperature of the copper. So, as long as you know your conversion, ayan, dito sa conversion natin ng temperature, meron naman ng given na mass, and eto lang, dito lang. As long as you know the specific heat capacity, ayan, given naman yung mga specific heat capacity natin. So, input lang natin sa equation, and then, there you go, okay na. Wait lang ha. Okay, so dito na naman tayo sa stoichiometry. So, dito tayo sa stoichiometry of thermochemical equation. So, we have discussed previously about sa stoichiometric calculation. So, medyo similar lang naman siya dito sa stoichiometry of thermochemical equation. Yun lang, dito may involve tayo na heat. Yan. So, a thermochemical equation is a balanced equation that includes the heat of reaction. So, we must keep in mind that the value refers, yung mga values natin later on, refers to the amount of substances and their states of matter in that specific equation. So, the enthalpy change dito sa stoichiometry of thermochemical equation natin, the enthalpy change of any process has two aspects. Ito yung sign and magnitude. Dito tayo sa sign, di ba? We have already discussed naman na the sign of enthalpy change or the sign of enthalpy depends whether the reaction is exothermic, di ba? Kapag exothermic, it is negative, or endothermic, it is positive. A forward reaction has the opposite sign of the reverse reaction. So, makikita natin dito the decomposition of 2 mole of water to its element. This is endothermic. So, ayan, kapag decomposition, ang change in the heat of reaction or change in enthalpy is 572. Ang reverse nito, the formation of 2 mole of water from its element, yung reverse ng equation na to, ang enthalpy change niya is negative 572. So, makikita natin na the opposite ay the forward reaction is just the opposite of the reverse reaction. So, kapag ni-reverse mo yung reaction, mag-change din yung sign natin. Next is the magnitude. So, the magnitude of the enthalpy, the change in enthalpy, is proportional to the substance reacting. So, in this example, let's say in this example, etong 286 kilojoule is thermochemically equivalent in 1 mole of H2. 1/2 mole of oxygen is thermochemically equivalent to 286 kilojoule. The same thing goes with our water here. 1 mole of water is thermochemically equivalent to 286 kilojoule. So, yung magnitude etong magnitude ng change in enthalpy natin is proportional to the amount of substance or to the mole of substance reacting. Yan. So, let's have an example. The major source of aluminum in the world is bauxite, mostly aluminum oxide. Its thermal decomposition can be represented by this reaction. If aluminum is produced this way, how many grams of aluminum can form when 1,000 kilojoule of heat is transferred? So, again, guys, just like our previous discussion sa stoichiometric calculation, before you proceed sa stoichiometric calculation, you must see to it that your equation or your reaction is balanced. So, dito sa given equation natin, balance naman na, pero later on, sa mga calculation nyo, i-check nyo kung balance na. So, bago kayo mag-proceed sa calculation, dapat balance muna yung equation natin. So, sabi natin, di ba, ang subject of interest natin dito is aluminum. So, we have 2 mol aluminum dito. So, ang 2 mol aluminum natin dito, ang 2 mol aluminum natin is thermochemical equivalent to 1,676 kilojoule. So, ang tinatanong sa atin, how many grams of aluminum can form when 1,000 kilojoule of heat is transferred? So, i-calculate natin. So, mass of aluminum is equal to, ang given sa atin, 1,000 kilojoule. So, dimensional analysis lang ulit to guys. Dapat ang mapalabas nyo na unit ay in terms of grams. So, 1,000 kilojoule times ayan, ang relationship natin dito, diba? Sabi natin, 2 mol of aluminum is thermochemical equivalent to 1,676 kilojoule. So, para makancel natin ang kilojoule dito, ang gagawin natin, 2 mol aluminum is thermochemical equivalent to 1,676 kilojoule. Times, to convert it to gram, diba, 1 mole of aluminum. Kindly check your periodic table. Aluminum, ano ang atomic weight niya?
26.98, ma'am.
26.98. So, cancel. Cancel ang mga unit natin. Makakancel yan, makakancel yan. So, ang natirang unit lang natin ay gram. So, this would be 32.20 gram aluminum. This is our final answer. So, di ba, madali lang?
Ma'am, mali.
Ano?
Ma'am, di ba 1,000 kilojoules plus divided by 167 na kilojoules, tas
167.6 to.
times 2 pala.
167.
13.2.
Tama? 1676. Tama lang ba? Mali?
Tama lang.
Okay. So, we are done sa yun lang, ganun lang, the same process lang itong stoichiometric, itong, tawag dito? Itong stoichiometry of thermochemical equation. So, yun lang, dapat alam nyo lang yung equivalent natin dito. Dito lang naman yung basis natin. Yung mole ng mga substance or compounds involved is thermochemically equivalent dun sa change in enthalpy na given sa atin. And then, makakancel nyo na yung mga unit and makakapag-come up na kayo sa needed or sa required value na hinahanap. Okay, so let's proceed sa Hess law of heat summation. So, dito naman, many reactions are difficult or even impossible to carry out in a laboratory scale. So, may mga reactions tayo na hindi possible or hindi pwedeng i-perform sa mga laboratory natin. So, isang ang tawag dito, anong term? Isang advantage or isang gamit ng ating mga enthalpy is yung kahit hindi natin ma-perform, even if we cannot perform these reactions in actual sa mga laboratory, pwede nating ma-determine yung mga heat involved sa mga reaction na to using the Hess law of heat of summation. So, ayan, the enthalpy change of pag sinabi natin Hess law of heat summation, the enthalpy change of an overall process is the sum of the enthalpy changes of its individual step. So, dito makikita natin dito sa equations presented, ito yung process in the industrial production of sulfur and sulfuric acid and the formation of acid rain. So, 'di ba, titingnan nyo pa lang to, it's impossible to do this in the laboratory, in the lab scale. But we can calculate the heat involved using the Hess law natin dito. So, dito sa equation 3, for us to be able to calculate, ang unknown natin dito is etong change in enthalpy dito sa last na equation natin. So, for us to be able to calculate this third equation, dito sa third equation, we must manipulate the equation 1 and equation 2. Meaning to say, kapag pinag-add natin etong equation 1 and equation 2, we must be able to come up dito sa equation 3 natin na ito. So, just like yung, hindi ko pala na-discuss pa sa inyo yung electrochemistry. So, dito, kapag pinag-add natin tong dalawang to, dapat makapag-come up tayo dito sa equation na to. So, let's try. So, ang mangyayari, sana yung okay, so dito lang muna tayo mag-focus sa dalawang equation na to. So, i-add muna natin para makapag-come up tayo dito sa equation na to. So, this will be S plus O2 plus wait lang. May mali tayo. Okay, so may nakalimutan akong i-mention. So, in Hess law of heat summation pala guys, yung element or yung compound of interest natin, dapat pare-pareho sila ng mole. So, let's say for example, eto sabi ko kanina, this is the equations involved in, or the reactions involved in the formation of sulfuric acid and in the formation of acid rain. So, dito, ang involved na element natin ay etong sulfur. So, dito sa first na equation natin, 1 mole of sulfur lang ang involved. While dito sa second equation natin, ang sulfur involved ay 2 moles. Ayan, 2 moles of sulfur. So, kailangan i-simplify muna natin to. So, magmumultiply tayo dito ng 1/2. Mag-multiply tayo dito ng 1/2. Kasi, para iisang mole lang tong involved dito, and iisang mole lang din tong involved dito, dapat pareho ng amount, or pareho ng mole ang involved. And then, since nag-multiply tayo dito ng 1/2, diba sabi natin kanina that the coefficient, the stoichiometric coefficient ng mga compound or ng mga element involved natin is thermochemically equivalent dito sa given na change in enthalpy natin. So, meaning to say, when we multiply 1/2 here, dapat mag-multiply din tayo dito ng 1/2. So, dapat mag-multiply din tayo dito ng 1/2. So, simplifying, ang mangyayari dito, Okay, so this is S plus oxygen. Wait lang, isulat muna natin lahat. Naging SO2 plus 1/2 O2 and SO3. So, simplifying, we have S plus oxygen plus SO2 plus 1/2 O2. This will yield SO2 plus SO3. So, simplifying further, 1 mole of O2 minus 1 plus 1/2 mole of O2. So, mangyayari dyan ay meron tayong S plus.
Ma'am, di ba po pwedeng makancel yung SO2?
Yes, makakancel na siya kasi kapag linipat natin sa kabila, SO2 minus SO2, so cancelled na yan, tama. So, ang ating magiging final equation will be 1O2 plus 1/2 is 3/2 O2, and this will yield SO3. Kaya, naging ganito yung equation natin. So, pinakita ko lang kung paano natin nakuha tong final equation natin na ito. So, later on, kapag may mga problem na ganun, so, dapat alam nyo kung paano nakuha tong final equation natin na ito. And then, for us to be able to calculate na itong enthalpy ng equation 3 natin, so, this will be change in H3 is equal to this, diba, Hess law of heat summation. So, kukunin lang natin yung summation ng 1 and 2 natin. So, this will be negative 296.8 plus, ayan, negative, 1/2 ng 198. This is plus negative 99.2. So, our final answer, ang ating H3, would be negative 396 kilojoule. So, that's it. Nakakasunod pa ba? May tanong? Do you have any question? Wala naman. Okay. Kung wala, let's proceed. Ayan. So, another example. Two gaseous pollutants that form in auto exhaust are CO and NO. An environmental chemist is studying ways to convert them to less harmful gases through the following equation. Given the following information, calculate the unknown. So, ang unknown natin is ito. Ito ang unknown natin. So, how will we calculate this one? So, try to do this on your own muna bago tayo mag-proceed. So, the same process lang din dito. Etong final na equation natin na ito ay nakuha natin by manipulating these two equations. Paano gagawin natin?
Bali po roughly negative 373 yung sagot ko ng delta H.
Yeah, tama. So, paano nangyari yon? Okay, let's try to calculate this one. So, for the sake of mga hindi pa nakakakuha, ang magiging final equation dapat natin is CO, NO plus, ayan. So, wait lang. Bakit? Magsulat. Si Jem ba yung nagsasalita? Okay, so
Ma'am.
ang CO natin, so dapat ang NO natin is nasa reactant. So makikita natin dito na kapag pinag-add natin etong what do you call this one? Pag pinag-add natin etong equation natin, nasa reactant side yung NO natin. So i-inverse lang natin to, magiging 2NO. 2NO.
Tapos i-divide po sa 1/2, ma'am, di ba?
Oo. Control E. So this will be N2 plus O2. And since nag-change yung, sabi natin kanina, 'di ba, dun sa sign natin, remember dun sa two variable na involved ay tawag dito, yung two factors na nag-discuss natin kanina, when we inverse an equation or a reaction, mag-change din yung sign natin. So, since in-inverse natin etong equation B natin, so magiging negative 180 din to. Negative 180.6 kilojoule. But since, ayan, makikita natin dito, CO plus NO. Dapat NO lang. Ibig sabihin, ang stoichiometric coefficient natin dito is 1 lang dapat. Pero dito, ang stoichiometric coefficient natin is 2. So, ang gagawin natin, mag-multiply tayo dito ng 1/2 to eradicate yung 2 natin. So, magiging times 1/2. Kasi nga, ang stoichiometric coefficient natin dito is 1, dito is 2. So, para ang magiging final equation natin ay eto, kaya tayo magmumultiply ng 1/2. Kaya, magiging, simplify na lang natin. Kaya, magiging 2. Ito is magiging 1/2. Ito din, may 1/2 din dito. And this will become 90 this will become negative 90.3 kilojoule. 0.3 kilojoule. So, kapag pinag-add natin, our final answer would be ito, negative 283 plus 90.3. Our change in H would be negative 373.3 kilojoule. Okay ba? May tanong? Wala? Okay, let's proceed sa next. Wala nang tanong dito? Wala nang tanong dito sa summation? Wala na ata. So, let's proceed sa next. Dito naman tayo sa standard enthalpy of formation. When we say standard enthalpy of formation, this is the standard reaction enthalpy for the formation of the compound from reference states. So, ibig sabihin, kapag sinabi natin na reference state, ito yung at standard condition, or ito yung pinaka-stable na form. Let's say for example, dito sa equation natin dito, this is graphite, or ito yung one form of carbon, di ba? Graphite, ito yung pinaka-stable na form ng carbon natin. yung pinaka-stable. So, ibig sabihin, ang standard reaction enthalpy nito is 0. Ito din, ang oxygen naman natin, ang pinaka-stable na form ng oxygen, di ba, meron tayong iba't ibang form ng oxygen. Meron tayong O2 and meron tayong O3. But among the two, ang mas stable ay yung what do you call this one, yung O2. So, dito, ang enthalpy ng oxygen natin is 0. So, dito, kapag nag-react ang carbon natin with oxygen, ang ma-form natin na product ay carbon dioxide. So, etong carbon dioxide natin, ang standard reaction enthalpy nito, or the standard enthalpy of formation niya is negative 393.5 kilojoule per mole of carbon dioxide. So, kapag sinabi natin na standard, again, kapag sinabi natin na standard enthalpy of formation, this is the enthalpy of formation of the compound from reference states. Ibig sabihin, from reference states, this is the most stable form at standard condition. For the case of carbon, the most stable condition of carbon is the graphite, and for the oxygen, the most stable is the O2 na form niya. Meron din tayong tinatawag na standard enthalpy of reaction. So, eto namang standard enthalpy of reaction. Ito yung enthalpy, or ito yung heat involved sa mga reaction. So, ang equation natin dito ay the standard enthalpy of reaction is equal to the summation of the product, the enthalpy of the product, minus the summation of the enthalpy of the reactant. So, ang nangyari in this hypothetical reaction like this, ang magiging standard enthalpy of reaction natin would be, ayan, yung coefficient natin, unahin natin tong product. Ayan, the product, the summation of the product. So, 3 times the enthalpy of enthalpy ng C natin, plus 4 times the enthalpy ng D natin, minus the summation of the enthalpy of the product, of the reactant. Okay, so, dito, A times ang coefficient naman niya is 1, so this is the enthalpy of our A here, minus the enthalpy of our B times the coefficient. So, ganun lang. This is how we calculate the standard enthalpy of reaction. So, yun lang, the total enthalpy of the product minus the total enthalpy of the reactant. Meron din tayong tinatawag na standard enthalpy of combustion. Ito naman, this is the standard enthalpy of reaction is specific for combustion, expressed in terms of 1 mole of burnt substance. So, ang reaction natin ng combustion, i-ano lang natin, i-introduce ko lang yung tawag dito, reaction natin for combustion. So, ang combustion natin, guys, this is hydrocarbon. Hydrocarbon meaning to say, ito yung alkanes natin, yung methane, ethane, ganyan, hydrocarbon, plus, para mag-ignite or magkaroon tayo ng ignition, meron tayong involved na oxygen. meron tayong involved na oxygen. This will yield carbon dioxide plus water. So, ito yung reaction, or ito yung reaction na involved kapag combustion ang pinag-uusapan natin, guys. Sa hydrocarbon plus oxygen, it will always yield sa carbon dioxide plus water. So, ito ang nangyayari kapag combustion. Standard enthalpy of reaction is specific for combustion expressed in terms of 1 mole of burnt substances. So, ito, standard enthalpy of combustion is equal to ayan, yung coefficient ng carbon dioxide natin plus the enthalpy plus the coefficient ng water natin times its enthalpy minus the fuel. Etong oxygen natin dito hindi nakasali dito sa reaction, dito sa equation natin kasi 'di ba? This is the most stable or the most stable form of oxygen, so zero na 'yan. 'Di ba? Sabi natin kanina na kapag stable, since this is the reference na state natin, so zero na siya. Kaya hindi na siya nasali dito sa equation natin. So dito, let's say dito sa example natin, example equation natin, this is the combustion of glucose. So glucose is a hydrocarbon. So, the combustion of glucose, ang involved dito na enthalpy of combustion natin ay negative 2,808 kilojoule per mole. So, ang interpretation nito ay 2,808 kilojoule of heat is released if 1 mole of solid glucose is burned completely. Pero, let's say for example na ang coefficient natin dito ay 2. Ang coefficient natin dito ay 2. Dapat i-simplify nyo yan kasi ang sabi, it must be expressed in terms of 1 mole of burnt substances. So, dapat ang coefficient natin always for hydrocarbon ay 1. Always, ang stoichiometric coefficient ng hydrocarbon natin ay 1. Okay, let's have some example. So, dito, what is the enthalpy change for the reaction, for the given reaction, given that the enthalpy of formation are negative 687 and negative 92 kilojoule per mole respectively. So, ang mangyayari dito ay what is the enthalpy change? Is equal to, so product minus reactant. So, sa product natin, meron yung so this will be 4 times negative 92 minus negative 687. So, what would be our answer? Ganito lang guys, negative change in H is equal to enthalpy of the product minus the enthalpy of the reactant. Pag-compute nga, anong magiging answer natin? 300? Hindi ko wala akong calculator dito.
Hindi po,
329.
3?
329 po.
329 kilojoule per mole.
$319 pala ba?
319. Okay, dito naman. What is the standard enthalpy of formation for glucose given the following? So, dito, para malaman natin kung anong magiging standard enthalpy natin, kailangan alam muna natin yung reaction. So, yung glucose natin kanina ay, ano yung glucose natin? Nasaan na? So, this will be C6 H12O6 plus 6O2. This will yield 6CO2 plus 6H2O. So, eto yung equation natin for standard enthalpy of combustion. So, this will be change in CH is equal to 6. Dito muna tayo, product. 6, ang ating carbon dioxide ay negative 393. Negative 393.5. Plus, ngayon, ng H2O, H2O natin ay 6 times negative 285.8 minus, what is the, ito yung tinatanong pala, the standard enthalpy of formation of glucose. Minus, saan yan? Ito pala ang unknown natin dun sa problem. Ito, standard formation. So, ang unknown ay ang standard formation ng glucose. So, given sa atin ang standard combustion. Given, no? Ayan. Negative 2808. So, ito ang unknown natin. So, ano ang answer natin? So, change in F, change in standard enthalpy of formation would be pakisolve nga. Ang sagot natin, guys,
Negative 1267.8, ma'am.
Negative. Tama ba? Tama. Nakuha din ba ng iba?
Yes, ma'am. Nakuha ko din.
Same po.
Okay. Ayan, negative.
Negative 1267.8 po.
1267.8 kilojoule per mole. So this is our final answer. And last example natin. What is the standard enthalpy of formation of methane? Pag-solve, paano natin solve to? What is the standard enthalpy of formation of methane? Okay, so paano ang gagawin natin dito? Dapat ang magiging final na equation natin is this one. What is the standard enthalpy of formation of methane? So ang final equation natin is this one. So manipulate this three. Manipulate nyo tong tatlong to para makapag-come up tayo ng gantong equation. So, ang mangyayari ay meron tayo ditong 2H2. Dito, isa lang ang H2 natin. So, magmumultiply tayo dito ng 2. So, magmultiply tayo dito ng 2. Tapos, etong methane natin is in the product side. So, dito nasa reactant sa. So, i-reverse natin to. So, magiging positive siya. Magiging positive 890.3 kilojoule. And just add this 3 para makuha natin yung final answer natin. Negative 395. $74.8 nakuha nyo ba?
Ma'am, negative po.
Yeah, negative 74. 74.8 kilojoule per mole. Nakuha ba, guys? Nakuha ba kung bakit tayo nagmultiply ng 2 and bakit naging positive tong sign natin dito? So, ulitin natin. So, our final equation is in the form of this one. So, dito, ang C natin, tama na. So, wala na tayong i-change dito sa first equation natin. Second equation natin, ang H2 natin, ang hydrogen natin, ang coefficient niya dapat is 2. Dun sa final equation natin, ang coefficient niya is 2. So, para maging 2 ang coefficient natin dito, mag-multiply tayo ng 2. Kaya, but then, sabi natin, ang enthalpy is an extensive process. Extensive meaning to say, yung kung yung amount ng substance natin is dependent dun sa mass or dito sa equation natin dito, dependent siya sa mole natin. So kapag nagmultiply tayo dito ng 2, magmumultiply din tayo dito sa enthalpy natin. So nagmultiply tayo dito ng 2 since nagmultiply tayo dito ng 2. And then sa last equation natin, ang CH4 natin, ang methane natin must be in the product side. Dito sa final reaction natin, it must be in the product side. Pero dito sa third reaction natin, nasa reactant side siya. So, para maging sa product side siya, ni-reverse natin to. And sabi natin kanina, kapag ni-reverse natin ang reaction, mag-change din yung sign natin. So, from negative 890, magiging positive 890.3 siya. So, just add this 3 and we can be able to come up with this answer. So, ito ang final answer natin. So, do you have any question? May tanong ba? May tanong tayo. So, in preparation for your exam, I will be sending problem sets. Okay lang ba? Mag-send ako ng problem sets? Or hindi?
Yes, ma'am, okay lang po.
Okay. So, I will be sending problem sets probably mamaya or kung makakagawa ako mamaya after ng mga klase natin for today. So, isi-send ko mamaya. Pero kung hindi, bukas na lang. Ha? So, wala na bang tanong?
Ma'am, pwede po pa-send yung PPT.
Yes, isi-send ko later.
Sige po, ma'am. Thank you po.
Wala nang tanong?
Ay, ma'am.
Okay, oh.
Ma'am, yung problem set po ba is like required namin ipasa sa pasukan or for practice problem?
Ano kaya? Sige, practice problem na lang. It's up to you kung solve no o hindi.
Ma'am.
Oops.
Ma'am, lahat po ba ng topics na na-discuss included sa exam po?
Siguro, i-review nyo lahat.
Sige, thank you po, ma'am.
Ma'am, open formula po ba sa exam?
Hindi,
Ano yung constants? Pwede ako constant.
Anong constant ba? Yung constant lang naman natin is yung mga R, di ba?
Kahit yun lang.
Ha? Yun lang yung
1/16 lang ng...
wag na. Yun lang naman. Konti lang yun.
Ma'am, ilang items? Ma'am,
Then, Chem. Hindi ko pa alam. Gagawa pa lang ako. Sabihan ko na lang kayo.
May concepts ba?
Meron. Siyempre, para naman may use yung mga pinagdi-discuss natin na concept kahit